So over the last few sections, we have learned all about common JavaScript data structures and also strings. But now it's time to turn our attention onto two additional ways of representing data: numbers and dates. Now, these might be a bit less important than things like strings and arrays, but you should still know how to use them. And so in this section, we will continue working on the Bankist app, but now we will incorporate numbers and dates and also internationalization and timers, which are another two very important aspects that you should actually know about. Let's start this section by learning how numbers work in JavaScript, how to convert values to numbers, and also how to check if certain values are numbers or not. And before starting this section, go ahead and open up your starter files for this section so that we can take a look here at the script.js. So as I said in the last section, in this one we will continue working on our Bankist application. Okay. Now, what's different here is that now we have actually different data. So we have only two accounts now here, and each account now has a new array which contains the dates of the movements. We also have the currency property and a locale property. All right. And so we will use this data in later lectures of this section. Okay. Then down here we have the complete application that we built in the last section. And if you want, you can go ahead and replace this entire code that I have here with your own code from the last section. Okay. What matters here is that we make the application work just as it was working by the end of the last section. All right. So again, we have the same application, only the starter data is a little bit different, but everything else is the same. And so now let's start learning a little bit about numbers. And the first thing that you should know about numbers is that in JavaScript, all numbers are represented internally as floating point numbers. So basically always as decimals, no matter if we actually write them as integers or as decimals. So we can show that by doing this. So we need a new terminal here. And so here is our application back again. Let's close this and open up the console. Give it some more space. And so you see that 23 is in fact the same as 23.0. Okay? And that's the reason why we only have one data type for all numbers. Also, numbers are represented internally in a 64 base 2 format. So that means that numbers are always stored in a binary format. So basically they are only composed of zeros and ones. Now in this binary form, it is very hard to represent some fractions that are very easy to represent in the base 10 system that we are used to. So base 10 is basically the numbers from 0 to 9, while binary is base 2, and so that's the numbers 0 and 1. Okay? So as I was saying, there are certain numbers that are very difficult to represent in base 2. And one example of that is the fraction 0.1. And that then results in very weird results like this. And this is kind of a classic or a running joke in JavaScript because this result should of course be 0.3 and not with all of these zeros here. But JavaScript simply has no better way of representing this number. So in base 10, 1 divided by 10 is simply 0.1. And so that's very easy to represent. But for example, if we were trying to do 3 divided by 10, then that is also impossible to represent for us, right? It would be this number here and 3 until infinity. Okay, And so in binary, the same thing happens with 0.1. So we get basically an infinite fraction, and that then results in a weird result like this one. Now, in some cases, JavaScript does some rounding behind the scenes to try its best to hide these problems, but some operations, such as this one, simply cannot mask the fact that behind the scenes they cannot represent certain fractions. And by the way, many other languages use the same system, for example PHP or Ruby, and so don't let anyone make fun of JavaScript because of this. Okay? So we just have to accept that it works this way because we really cannot do anything against this. So just be aware that you cannot do like really precise scientific or financial calculations in JavaScript, because eventually you will run into a problem like this. So point 2, which will result in false, which of course is incorrect, as we know. This should be true, but, well, this is simply an error in JavaScript that we have to accept. Okay? All right. Now that we know how JavaScript represents numbers, let's go back to actually working with them. So we know how to convert a string to a number, right? So that's like this. But there's also an easier way, so kind of a trick that we can use, which is to, or actually this should be a string, otherwise that doesn't make much sense. But as I was saying, there is an easier way, which is simply plus 23 the string. And this works because when JavaScript sees the plus operator, it will do type conversion. So it will automatically convert all the operands to numbers. And so therefore we see 23 here in both these cases. So in this purple color, which are numbers. So this here makes our code look a lot cleaner in my opinion. And so let's now actually go to our project and replace all the occurrences of number simply with the plus sign. So here, if I save it now, the prettier extension should get rid of the parentheses here, and it does. So here and here and here as well. And that should be it. Yeah, that's it. Great. And so our project will work the same, but the code is a little bit cleaner now. Okay, so here we converted strings to numbers, but we can also do something called parsing. So we can parse a number from a string. So on the number object, which is kind of this function here, but it's also an object in the end, remember, because every function is also an object. And this number object here has some methods to do parsing. So let's use parse int. And so here we can now specify a string, and that string can even include some symbols. And JavaScript will then automatically try to figure out the number that is in this string. All right. And so here we get 30. And this is actually a number. It's not a string. All right. Now, in order to make this work, the string needs to start with a number. So if we have something like this, then it's not going to work and we get not a number. Okay. So this is a little bit like type coercion, but even more advanced, because as we just saw, it tries to get rid of unnecessary symbols that are not numbers. And this can be very useful, for example, in this situation, where we get some kind of unit from CSS and then need to get rid of that unit. Now, the parseInt function actually accepts a second argument, which is the so-called radix. And the radix is the base of the numeral system that we are using. So here we are simply using base 10 numbers, so numbers from 0 to 9. And most of the time we are doing that, and so we should always pass in the number 10 here. Okay, so that can avoid some bugs in some situations, and you see the result here is the same. But if we were working, for example, with binary, then we would write 2, and then the result would be completely different. In this case, we cannot even see it, but let's just keep using 10 here. So this is with integers. So that's what the int here stands for. So parse integers, but there's also parse float. So number dot parse float. And let's now try 2.5 rem. And so now it reads the decimal number here from our string. So a floating point number. Let's see what happens if we used int. And then we only get the integer part, right? So it will then stop here at this decimal point. But that's of course not what we want. And by the way, we could even have like some white space down here that would not affect anything at all. All right. Now, by the way, these two functions here are actually also so-called global functions. So we would not have to call them on number. So this here also works. Okay, but this is the more traditional and old school way of doing it. Now in modern JavaScript, it is more encouraged to call these functions actually on the number object. Okay, so we say that a number here provides something called a namespace. All right, so a namespace for all these different functions like parse float and parse int. But anyway, let's now explore another function of the number namespace, and that is the isNan. So is not a number. So number.is not a number. And we can use this one to basically check if any value is a number. Well, not any value, but more about that later. So for example, if we pass 20, then here we get false. And so is it not a number? False, right? So let's try the same with the string 20. And so here we also get false, all right? Because this also isn't not a number. It's just a regular value, right? But now let's try it by converting something. So for example, this string, if we try to convert it to a number, then this will be not a number, right? And so therefore it is true. So let's just do that here. So yeah, this works as well. And so you see, this is of course not a number. All right. But let's try something else. Let's, for example, divide 23 by 0. And maybe you know that dividing by 0 gives us infinite. Okay, so dividing by 0 is something that's not allowed in mathematics. And so it will give us infinity. So infinity is also not a nan. And so therefore we get false here as well. So let me just demonstrate that here. So indeed, this gives us this special value of infinity that also exists in JavaScript. And so this is not a number is actually not a perfect way for checking if a value is a number, because it doesn't consider this use case. And sometimes this might very well happen. And therefore, there is a better method called isFinite. So number is finite. And let's try it with the same numbers. So here we get true. Okay. So basically, this should be the opposite now of this one, because this is not a number, but it is finite. Okay. Now, if we try it with 20, the string, then here we get false, because it's not a number. And so this is actually better to check if something is a number or not. And I know this sounds a bit confusing, and the confusion comes from the fact that we have this weird thing here that is also called not a number. All right. And so, and therefore, I'm just telling you that the isFinite method is indeed the best way of checking if a value is a number. So a real number, not a string. All right. So let's try again this one here, trying to convert it. And we know that this here is not a number. So literally, this will be NaN, right? And so this should be false as well. And it is. And now finally, this last use case, which gives us infinity. And so it is false as well. So that's where the name of the method actually comes from. So is finite. And so infinity is of course not finite. All right. And so this method is the ultimate method that you should use to check if any value is a number, at least when you're working with floating point numbers. So if you are sure that you just need to check for an integer, then you can use isInteger as well. So let me just write here a comment as well. So this one you should only use to check if value is not a number. So literally not a number, this value. Okay. But usually in practice, I never use this. Whenever I need to check for a number, this is the one to go. Or if I'm using integers, then I use isInteger, as I was just saying before. So we can do this. Also, this is also integer, remember. And so both are true. Okay. But then, of course, if we try this here, it will be false. Now, in our project that we're currently building, there is not really a need to check if any of the inputs is really a number or not. And so in this particular case, we don't need to go back and change anything. But it's still good to know about especially this method here. So this is your go-to whenever you need to check if something is a number or not. And going back here, the parse float function should be your go-to whenever you need to read a value out of a string, for example, coming from CSS. So then you always get this, and it's very nice to be able to read the number out of this string. Let's now learn about some more mathematical operations and also about rounding numbers. And we have already been using lots of mathematical operations. For example, plus, minus, times, divided, exponentiation, and so on. And so we don't need to go over these again. So let's start here with the square root. And so just like many other functions, the square root is part of the math namespace. So math.sqrt. So this stands for square root. And so all we need to do is to pass in the number, and then it will give us the square root. And the same could be achieved using the exponentiation operator as well, by doing 1 divided by 2. And so that 2 is the square. So we want the square root, so we use 1 divided by 2. And actually we have to put this into parentheses, and now it works. All right, and the same would work for a cubic root, for example, of 8, which would be 2. And so actually this is, I think, the only way you could calculate a cubic root if you need it. Next up, let's get the maximum value of a couple of values, okay? So again, we use math and .max this time. So let's just use a couple of numbers here. And so, as the name says, the maximum value gets returned to us. And this max function here actually does type coercion. So it should now still give us 23, okay? However, it does not parsing. So if we try 23 pixels, for example, it will then result in not a number. So this does not work. All right. And just as we have max, we also have min. Let's just put it back to 23. And now here we get 2. All right. Now, besides a couple of methods, there are also constants on the math object or on the math namespace. And so, for example, if we wanted to calculate the radius of a circle with 10 pixels, we could do that. So for that, we use math.pi. And for now, let's just take a look at that. And so it is this constant that you might know, probably. And so again, let's say that we get like 10 pixels from the user interface. So we can say parse float of 10 pixels. And then we simply have to square this value. This is how we calculate the area of a circle with this radius. All right. Now, another thing that is on the math object is the random function that we already have been using a couple of times. And it's very important to be able to generate good random numbers when we need them. So before, we have already created random dice rolls, remember? So that we did by math.random. And so this will give us a number between 0 and 1. So as I reload, you see I get different values. Then we multiplied this by 6. And then we removed basically the decimal part by doing math.trunc like this. Okay. Now the problem with this was that then the highest number could be 5. And so we simply added +1 to offset that truncation here. So that cutting off of the decimal part. And so now we're going to get values here between really 1 and 6. Okay, so this works great, but let's now generalize this formula into a function that we can then use as a random number generator. And this is going to be super useful in many apps that you're going to build throughout your career. Now, there is actually a problem with the implementation of this function in the first version of this video. And so you will see my screen change now because I re-recorded this part of the video later. But that's not a problem at all. And so let's now just start working on this random number generator. So we're going to create a function. Let's call it random int. And here we will pass in a minimum and a maximum value. So minimum and maximum, because we basically will want to generate a random number between these two values. And let's actually once again first call this function so that we actually see how we can use it. So for example, let's say we want a random number between 10 and 20. And so then this is how we would call this function. Or maybe we just want a random number, so a random integer between 0 and 3. And so these are all the different ways in which we'll be able to use this function. And so let's now actually build out this function here step by step, because this will teach you a lot about random numbers and how to generate them. So as always, let's start from math.random, which, as you already know, will gives us a random number between 0 and 1. Now, if we wanted to scale this, so basically if we wanted to have a number, for example, between 0 and 2, then we would multiply this by 2. So let's actually do that here first in order to understand how this is going to work, even though we already did this here many times before. So now we have with this here basically a number between 0 and 2, but it's not quite 2. It's more like between 0 and 1.999999, right? Because keep in mind that these are not integers. These are basically decimal numbers. And so now we will, before we can move on, actually take out the decimal part with math.floor. So basically rounding down this value. And so with this, we will now always get a number which is either 0 or 1, because again, this one here will stay between 0 and 1.99999 and so on. And so if we take off that decimal part, we will end up with 0 or 1. So with this right now, we can generate two different random numbers. And that's because we have this two right here. But of course, this needs to be dynamic. So it needs to respond to the minimum and maximum values that we input here. So here, for example, we do not want only two possible random numbers, but really 10, or actually 11, because this minimum and this maximum should also be included. So if we count from 10 to 20, that will actually be 11 numbers. Or here, it will be 4 numbers. So 0, 1, 2, and 3. So 4 numbers, right? So how can we get to these number of values that we want? Well, here, instead of hard coding this value, we just need to subtract the max from, or actually the other way around. So subtracting the minimum from the maximum. So in this case, that would give us 20 minus 10 is 10. And then here we would get 3 minus 0 is 3. Just remember that actually here we had not 10 different random numbers, but 11. And here not just 3, but 4. And so again, that's because both the minimum and the maximum should be part of the range. So to fix that, all we need to do is to add plus 1 here. All right. And so with this, what we have at this point will already give us the correct number of possible random integers. Now we're not done here yet, but let's already start to log the result here to the console of this one, just so we can see that we're on the right path. So let's get rid of this one here. So it's just this last result here. So if we keep updating, then notice how, of course, these numbers are not between 10 and 20 yet, but really more between 0 and 9, or probably 0 and 10. So if we reload this a few times, we should get all of these different numbers. So again, between 0 and 10, with both of these values included. So let's fix that. And so basically that's going to be the second step. So we already did the first step, which was basically to scale up this math.random, which initially is a number between 0 and 10, all the way to making it dynamic, taking into account our minimum and maximum. And so after this first step, now the possible number of random integers is correct. But now we need to basically then shift this range to the correct place. So basically that it can start not at 0, but really at 10 here. So all we need to do is just what I just said. So basically adding this value right here so that the range starts there. So here at the very end, so after all of this calculation here, we just add the minimum value. And so, beautiful, 19 is indeed between 10 and 20. And if we reload this a couple times, then you see here that now we already got the max value. So that's nice to know that it is indeed included. And it would be good to also get a 10 here just to make sure. But well, I'm not going to reload it a million times until I see it. But I'm sure that this is working just fine. Let's also maybe duplicate this here and try one between 0 and 3. And so this should be easier to get all of them here at least once. So you saw that we got a 3 before and a 2, now a 0. And so that means that our random int function here is absolutely correct and ready to be reused in any of your future project if you ever need some random number between two values. Now, as I change my screen back to the original, you will see the old incorrect implementation of this function. So please just disregard that function that you see on the screen now and use the one that we just coded earlier. Okay, next up, let's talk a little bit about rounding, and let's start by rounding integers. So you can add some comments to this here if you want, but I'm just going to leave it like this. I will just add here rounding integers. And so we have already been using math.trunc, right? So what this does is to simply remove any decimal part. And so we end up with 23 here, right? Let's just take this one out. All right. So again, this one simply removes any decimal part always. But we have also other ways. So we also have round. So math.round. And so this one will always round to the nearest integer. So this one is going to be 23 and the other one 24. Let's duplicate this a couple of times to save us some time. Then we also have ceil. And this one will basically round down. So both of these results should become 24. And so that's these two here. So line 318 and 20. Or actually, it's these two. So I'm confusing these numbers. All right. So both of these are 24 because they will both always be rounded up. And then we also have a floor. And so these two will both be rounded down to 23. And so that's what we get here. And by the way, all of these methods, they also do type coercion. So if we do this, then it's going to work just the same. Now you might think that floor and trunk are very similar. Let me just put this one down here. And indeed, they do the same when we are dealing with positive numbers. So basically, floor and trunk both cut off the decimal part when we are dealing with positive numbers. However, for negative numbers, it doesn't work this way. So let me compare them here. So trunk minus this and also floor. Okay, and so now this one here, just like before, gets truncated. So it simply removes this part, but floor now gets rounded to minus 24. Because with negative numbers, rounding works the other way around. And so actually, floor is a little bit better than trunk because it works in all situations, no matter if we're dealing with positive or negative numbers. And so here, let's go ahead and replace this with floor. So we're looking for a really generalized function here. So this random int function should work in all situations, even if we give it negative inputs here. And so therefore, we need to work with floor here. All right. So that's rounding integers. Let's talk about floating point numbers. Or we can also say decimals. And now with decimals, it works in a little bit different way. So let me show you how. So in decimals, we have to specify the number like this in parentheses. And then on that number, we call the toFixed method. Okay, and let's try it here with 0 first, just so we can see the result. And so you see that with 0, it is converted to 3. But this 3 is white here, while these other ones are pink or purple. And so this means that is actually a string, right? So toFixed will always return a string and not a number. And that's important to keep in mind. So if we set here instead of 0, the 3, then it returns 2.7 and it adds zeros until it has exactly 3 decimal parts, just like we specified here. All right. Now let's add something more here, like 2, 3, 4, 5. And let's say we only want 2 decimal places here now. So this should become 2.35. And indeed it does. Okay. And if we now wanted to convert this result to a number, then we simply would have to add the plus sign here. And then we already know that this here converts a string to a number. And indeed, now it is purple again. So with decimals, it works differently than with integers. And that's once again because things in JavaScript evolved kind of in a weird way in this kind of old language. And if the language was designed today, definitely this would be very different. But yeah, this is what we have to work with right now. Okay. Just keep in mind that this here works in a similar way than the string methods. So this is a number, so it's a primitive, right? And primitives actually don't have methods. And so behind the scenes, JavaScript will do boxing. And boxing is to basically transform this to a number object, then call the method on that object, and then once the operation is finished, it will convert it back to a primitive. Okay? All right. So once again, this lecture looked a little bit like a reference of a couple of different methods. But to make it a bit more fun, let's now apply some of this to our Bankist project. And the first thing that I want to do is to round the requested loan amount. So this one here. So this looks weird. Oh, it's because of this number. Okay. So we could use this application in this other page here on the other side, but I prefer to have everything here in one screen. But anyway, I can take a loan like this, right, with the decimal part. But in practice, I've never seen a bank giving out a loan like this. And so let's apply the rounding to the loan functionality. So that's here. And the rounding then needs to happen right here. So the value that we get from the loan here needs to be rounded down. Okay? And then we actually do not need to convert it to a number, because as I showed you before, the math.floor method actually does type coercion itself. Okay? And we are using floor here because we simply want to round any value down. All right? So in this case, it would have been 150, and that's it. So let's try that again now. So let's ask for 150.56. And so now we get just this. Okay, probably I added one more zero there, but that doesn't matter. Next up, let's use the toFixed function or method to make our numbers here look a little bit nicer. So here, for example, we have this decimal part with the two numbers, but here then we only have the 0.9. And so this should be like 0.90. And here it should be 1300.00. And the same also up here. All right. So for that, we can use the toFixed function that we just learned about. And so let's do that in all the places where we display numbers on the screen. And so that's in these three functions. So display movements, display balance, and display summary. So let's start here at the top. And so here we have the first occurrence. So this movement here is a value, so it's a number that we display. And so on here, we can simply call, so .toFixed, and then with two decimal parts. All right. And now let's just copy this from here. So display balance. So let's do the same here. And the same in the summary. And so that will then hopefully also fix this weird, really long number that happens because of the rounding errors in JavaScript that I just explained to you in the previous lecture. So everywhere we print a number, I will do this now. So, okay. Then also on this result, and also on the interest. Let's give it a save. And that's a lot better. So it worked. You see, now we get 0.00. And here we also get nicely 0.90. And the same down here. We are now back to having just two decimal places, just as we requested, so to say. So this lecture was kind of a short overview of some more math functions, including some rounding, and also some other stuff like getting the max and the min value. And yeah, so good to know functions. And of course, there are a lot more. So if you need something like logarithmical functions or sinuses, then of course you can always check out the MDN documentation. One operator that I didn't mention in the last lecture is the reminder operator. And the reason for that is that the reminder operator has actually some special use cases, and so it deserves a lecture on its own. So what is the remainder operator? Well, as the name says, the reminder operator simply returns the remainder of a division. So let's check that out. So the remainder operator is this one. So the percentage sign. And so let's check what 5 remainder 2 is. And it is 1. So why is that? Let's say we divide 5 by 2. And so then we get 2.5. But if we took only the integer part, so only 2, then the result would be 2. Okay? So if we did the division only until the integer part, then that result would be 2, because 2 times 2 is 4, but then there would be the remainder of 1, right? Because 5 minus 4 is 1. So we can say that 5 is 2 times 2 plus 1. All right, and so this here is the remainder, and therefore 5 remainder 2 is 1. Well, let's try another one. Let's say 8 remainder 2, or 3 actually. And so now the remainder is 2. Okay, and if we did 8 divided by 3, then we would get this number here. But again, if we only took the integer part, so 2, then we would only end up with 6. So 2 times 3 is 6. So let's write that. 8 is 2 times 3. So this 3 here times 2 plus the remainder, which is 2. So 6 plus 2 is 8. And so 2 is that remainder. And therefore, that's the result that we get here from the remainder operation. All right. So maybe you're not yet familiar with this concept, and so I hope that it made sense. Now, one thing that is many times useful in programming is to check whether a certain number is even or odd. So even numbers are 0, 2, 4, 6, 8, 10, and so on and so forth. And the odd numbers are all the others. So 1, 3, 5, 7, etc. So when is a number even? Well, it's even if it is divisible by 2. And divisible by 2 means that if we divide it by 2, the remainder is 0. So let's check that. So 6 is an even number, right? And so the remainder of dividing it by 2 is 0. And that's because dividing 6 by 2 is an integer number. So it's exactly 3. So 3 times 2, so this 2 here gives then 6. All right? But on the other hand, an even number is, for example, 7. All right? And so here we have the remainder as 1. And that's because 3 times 2 is 6. And then plus 1, which is the remainder, is 7 again. And so just like 5, which is also an odd number. Okay? And so now we can use that knowledge to check whether a certain number is even or not. So let's create a function is even, and a simple arrow function is perfect here. So if the remainder of n with 2 is equal 0, well then of course this will return true. and otherwise it's going to return false. So when it's 1, then the result of this function will be false. So let's use this. Is even, let's try with 8, 23, and maybe, well, something else, doesn't really matter. And so intuitively, we know that 8 is an even number, and so we get true. This one is an odd number and an even number, and therefore we get the correct results. Okay? And so, of course, this works to check if any number is divisible by any other number. All right? And whenever the result of the reminder operator is 0, then that means that the first number is completely divisible by the second one. And again, this is sometimes very important to know in programming. So let's see another example here involving our application. Not really in practical terms, but just to have some fun. So let's select all of the rows of our movements. So yeah, let's check the HTML here. So each of the movements is this row, so this element with this class. And so let's select all of them, and then we will paint them a little bit based on some conditions. So let's select all of these elements. So all. So that's dot, and then this class name. And so this here will return a node list. And so let's convert it to a real array. And for that, this time I'm going to use the spread operator. So I will spread all of these elements into this newly created array. And then on that array, I can immediately call for each. And so let's specify a callback function with the current element, which is the current row and the current index. All right. And now let's say that I wanted to color every second row of the movements. So all I have to do is to check if the current index is divisible by 2. So I, which will start at 0, then it's going to be 1, 2, 3, 4, and so on and so forth. So if I want to color every second row, then if I do this, then every second number will be divisible by 2, and every other second number will not. So I can just check if it's 0, and if it is, then I take the current row, take the style, and change the background color. And remember that we have to use camel case notation here. And let's change it to orange red. So just to make it a little bit fun. Okay. And actually, just like before, this here actually has to happen inside of a handler. So an event handler function, because this code here will execute right when we start our application. But then as we log in, we overwrite that with the deposits of the current user. And so let's again do that as we click here on this balance, just so that we have like any reference point. Okay. And now let's try this again. All right. And now as I click this label, well, like magic, every second row is now painted in orange red. So beautiful, right? Well, not really, but at least we know that our code worked. All right, let's do another one. So now let's say that I want to paint every third row also in even another color. And so I do the reminder of 3. And each time it is equal to 0, then I do set this background color to blue. All right. And so this here will be at 0, 3, 6, 9, and so on and so forth. While this one here is going to be, as we already saw, at 0, 2, 4, 6, and so on. And you see that there's going to be some overlap here, but that's not a problem. Here we are missing the R. Give it a save, and just try it one more time. So this is just for fun, of course, but there could be real applications to this. So you see that now every third row is indeed blue. So really nice looking effect that we just created here. But yeah, it's just to illustrate really how the reminder works. So whenever you need to do something every nth time, so to say, so every nth time, then it is a good idea to use the reminder operator for that. So here, for example, every second time, every third time, but of course this might then depend on your specific need, maybe in your application. So this is how we use the reminder operator, yet another one in your toolbox now. And with that, let's go straight to the next video. Starting from ES 2021, we can use a feature called numeric separators to format numbers in a way that is easier for us or for other developers to read and to understand. So let's say that we wanted to represent a really large number. For example, the diameter of our solar system. So let's say diameter, which is 287 billion and 460 million. And just from looking at this number here, it's really difficult to read and to understand it. So does this mean like 28 billion, or is it just 2 billion? Or really, what is this number? It's really hard to read like this. There's just too many zeros here, right? Now, to help with this, when we write a number this large in the normal English language, we usually use a thousand separator like the comma. So we would write this number like this, right? And then it becomes really easy to immediately see that this means 287 billion and 460 million. And now, fortunately, we can do the same thing in JavaScript as well, using the new numeric separators. So numeric separators are simply underscores that we can place anywhere that we want in our numbers, and which will make it then really easy to understand and to parse numbers this large. So using the underscore here as a thousand separator then makes it really easy to understand that this number here means in fact 287 billion. Now let's just log it to the console to see what JavaScript actually sees. And so here we see that in fact the engine basically ignores these underscores, so these numeric separators. It simply sees the number itself. And so what this means is that we can actually place the underscores, so the numeric separators, anywhere that we want. So let's do another example. Let's call this one price in cents, and I'm going to set it to 345_99. And so again, using the underscore here then makes it really obvious that this is actually a price in cents. So of course the number itself does again not contain the underscore, and so our price is indeed 35,599 cents. But by placing the underscore here, it makes it really obvious that we have first this value here and then this other value here in cents. And in fact, it's so obvious that we could even get rid of the cents part here in the variable name, right? So basically, we can use the underscore now to give meanings to certain parts of our numbers. So here we said that these are thousands, and here we said that these are cents. So let's try another one. Let's call this transfer fee. And here again, we place the underscore like this. And so here immediately it looks like it is $15, for example, and 0 cents. But if we did the same thing like this, so placing the underscore here, then it suddenly looks like 1,500, right? While in fact, it is the exact same number. So both of them are exactly 1500s, but just the underscore alone gives them different meanings. And so we can use that to our advantage whenever we write numbers in our JavaScript code. Now, another variable here called pi, and this one is to show you some restrictions as to where we can place the underscore. So pi is 3.1415, and we can only place underscores between numbers. So we could place it here, and there would be no problem at all. Let's just log it. But actually the underscore doesn't make a lot of sense here. So let's remove it, and let's say we wanted to place it here. Well, here we get then an error because that is not allowed. It's also not allowed to place here, and also not at the beginning of a number or at the end. So all of these are illegal, and yeah, like this it works, but we can also not place 2 in a row. So the error message here is pretty explicit about that. Okay, and now just one final detail that we need to be aware of is that when we try to convert strings that contain underscores to a number, that will not work as expected. So let's try to use the number function that we learned before to convert a number. So of course with this it should work just fine, right? So we have 230,000 the number, or actually the string, and then here it converts to a number. However, if we place an underscore here, so if we wanted to have a numeric separator here, that would not work. So now it is not a number. So what that means is that you should really only use these numeric separators when you are writing down numbers like this. So really in the code. If you need to store a number in a string, for example in an API, or if you get a number as a string from an API, you should not use underscores in there, because then JavaScript will not be able to parse the number correctly out of that string. So it's not going to work as expected, and you will get this not a number that might then introduce bugs into your application. And the same is true with the parse int function. So here we do not get not a number, but we only get the 230. So only the part that is here in front of the underscore. Everything else will then be ignored. Let's now meet one of the primitive data types that we never talked about before, and that is big int. So big int is a special type of integers that was introduced in ES 2020. And so let's quickly take a look at it. So we learned in the first lecture of the section that numbers are represented internally as 64 bits. And that means that there are exactly 64 ones or zeros to represent any given number. Now, of these 64 bits, only 53 are used to actually store the digits themselves. The rest are for storing the position of the decimal point and the sign. Now, if there are only 53 bits to store the number, that means that there is a limit of how big numbers can be. And we can calculate that number. So that's 2 elevated to 53, and then minus 1 because the numbers start at 0. And so that is this gigantic number right here. And so this is essentially the biggest number that JavaScript can safely represent. Okay? Or actually it's 53. So this is the biggest number. All right? And it is 2 because, again, we are working with base 2, which is only zeros and ones. And this number is so important that it's even stored into the number namespace as max save integer. So this gives us the exact same number. All right. So any integer that is larger than this is not safe. And that means it cannot be represented accurately. So let's duplicate this line here. And for example, add 1 to this. And so you see that this is not correct, right? It only added one number to this one where it should have been added to. So if we do this, then we get the exact same thing. So we keep adding numbers here, and they are always the same. And so that means that JavaScript can simply not represent these numbers accurately. And so if we do calculations with numbers that are bigger than these, then we might lose precision. Okay? So in some numbers, it does actually work for some reason, but that's because JavaScript behind the scenes uses some tricks to still represent some of the unsafe numbers. But again, sometimes that works, sometimes it doesn't. And so that's why we call these unsafe numbers. So you see, sometimes these numbers are, or at least look correct, and sometimes they don't. Okay? So this can be a problem sometimes, because in some situations we might need really, really big numbers, way bigger than this one here. For example, for database IDs, or when interacting with real 60-bit numbers. And these numbers are actually used in other languages. And so we might, for example, from some API, get a number that is larger than this, and then we have no way of storing that in JavaScript. At least not until now. Because now, starting from ES 2020, a new primitive was added, which is called big int. All right? And big int stands for big integer, and it can be used to store numbers as large as we want. So no matter how big. All right, so let's say we need this number, and I'm just using random numbers here. So if I log this, then you see, well, this here, which probably does not have precision because, of course, it's larger than this. But if I use the n, then this will be a big int. So let's see that. And so this n here basically transforms a regular number into a big int number. And you see in the console here, it then also does look different. Okay? So this is a really, really huge number. But now JavaScript has a way of finally displaying this number here accurately. All right? We can also create big ints by using the bigint function. So sometimes that's necessary, and then without the n. And so this gives us kind of the same result. Well, not really for some reason, but I guess it is because JavaScript will first have to still represent this number here internally before it can then transform it into a big int. And that's the reason why here from a certain point on, this second number is different. So this constructor function should probably only be used with small numbers. For example, like this. Okay, so this is how we create big int numbers. But let's now see some operations with these numbers. And, well, basically it's very simple. All the usual operators still work the same. So let's say we have 1 or 10,000 n plus 10,000 again. And so in this case, of course, we wouldn't even need a big int here, but this is just to demonstrate that the operators work just the same with big int. So we get indeed 20,000. And the same is true with other operations. So for example, a multiplication, let's try a really huge number, 10 times this other huge number. And so it then gives us this result. Now, what is not possible is to mix big ints with regular numbers. So let's say we have huge. So some random number like this. And then we have a regular number, which is just 23. And so if I wanted to multiply them, so huge times num, then we would get this error. Cannot mix big int and other types. All right. And so this is where we then would have to convert this number here to a big int. And this is where the constructor function that I showed you here becomes necessary. And so now it is indeed going to work. However, there are two exceptions to this, which are the comparison operators and the plus operator when working with strings. So let's see that. So we can still do a big int and then, for example, greater than a normal number. So this still works and we still get true as expected. Okay. However, when we do this, so 20n equal 20, we will get false. But that makes sense because JavaScript, when we use the triple operator, does not do type coercion. And in fact, these two values here, they have a different primitive type. This is a regular number and this is a big int. In fact, we can check that, or at least I think we can. I never did this actually. But yeah, indeed, the type of this is a big int. All right. But however, if we do the regular equality operator, so the loose one, then this should still be true, right? Because then JavaScript does the type coercion, and so then it will coerce this one to a regular number, and then they are both the same. So just like, so it would even work like this. So this is one exception. Let's write that here. So logical operators are one exception, and the other exception is when we do string concatenations. So let's say huge plus, and then some string here is really big. And so you see, in this case, the number is then actually converted to a string. So even the big int number. Okay. Now, one other thing that I didn't tell you up here is that also the math operations that we talked about earlier are not going to work here. For example, we cannot take the square root like this, QRT of 16n. All right, so that doesn't work. All right. Finally, let's take a look at what happens with divisions, because big int is indeed an integer. So what happens if we do this? 10 divided by 3n. And we know that with normal numbers, this would not be an integer, right? So 10 divided by 3 is 3.33 until infinity. So here. But with big ints, it will simply then return the closest big int, right? Let's try it with 11 here. And so it simply basically cuts the decimal part off. Of course, with 12, it would then be 4, right? But with anything else, it will then cut off the decimal part. Okay, and basically, this is all that I have to tell you in an introduction video like this one about big int. So this new primitive type adds some new capabilities to the JavaScript language when you really need to work with like huge numbers, just like this one here, for example. Now in practice, you will probably not use this very much, but it's still good to know that big int exists and also how it works. When we build real-world applications, one type of data that comes up all the time is dates and times. So let's learn the fundamentals of dates and times in this video so that in the next one we can then implement them into our application. Now, dates and time can be a little bit messy and confusing in JavaScript. And so just like with numbers, I will try to make the fundamentals here as clear as possible. So first, we need to actually create a date. So create a date. And there are exactly 4 ways of creating dates in JavaScript. I mean, they all use the new date constructor function, but they can accept different parameters. So let's see how. So the first way is simply to use the new date constructor like this. And then we can assign this to a variable. And let's just call it now. And then here I'm logging now to the console. And so we get the current date and time at this very moment. So you see that Sunday, August the 2nd, 2020, and plus this time here. Next up, the second way is to parse the date from a date string. So again, we use new date, and then we can pass in a string. And for example, this string here would work just fine. For example, just this part here. Okay, so simply giving JavaScript a string here, and it will then automatically parse the time based on that. And so that's the second date that we get here. But we can also, of course, write a string ourselves. For example, let's try Christmas here. So we can even write December 24, 2015 or something. And so indeed, that works. And we even get the day of the week here. So JavaScript is pretty smart in parsing out this string that we write here. Now, however, it's generally not a good idea to do this because it can be quite unreliable. All right. However, if the string was actually created by JavaScript itself, then of course it is pretty safe. So actually in our accounts object, or in our account 1, for example, we now have these dates, so movement dates. And so let's try to parse this string here. So let's create a new date object in JavaScript based on that string. So that's in account 1 dot movement dates and then 0. All right. So again, this is okay because it was JavaScript who created that date that I just showed you there. So this date here. And by the way, this Z here means the UTC. So that's the Coordinated Universal Time, which is basically the time without any time zone in London and also without daylight savings. So that's based on a string, but we can also pass in year, month, day, hour, minute, hence even second into this constructor. So let's say 2037 and 10, 19, 15, 23 minutes and 5 seconds. So indeed, we get November 19, 2037 at 15 hours, 23 minutes, 5 seconds, just as we have here. Now you might have noticed that here we have 10, but November is actually the month 11, right? And so that means that the month here in JavaScript is 0 based. And that's a little bit weird, but well, we can just get used to that, right? Now, what's cool about this is that JavaScript actually auto-corrects the day. So let's try this here again differently. So let's try November 31st. But we know that November only has 30 days, right? And so if we take a look at this, it will then auto-correct right to the next day. So that's going to be December 1st. And we can even try November 33rd, which should then be December 3rd. Okay, so this sometimes is actually pretty useful. Finally, we can also pass into the date constructor function the amount of milliseconds passed since the beginning of the Unix time, which is January 1st, 1970. So let's see that. So again, new date. And if we pass in 0, so 0 milliseconds after that initial Unix time, then indeed we get January 1st, 1970. Okay, and this will actually be pretty useful, even though it looks a bit strange. And let's now create a date that is 3 days after this. And so that is essentially 3 times, which is 3 days, and 1 day is made out of 24 hours, which is made out of 60 minutes, which is made out of 60 minutes, which is made out of 1000 milliseconds. And so this is how we convert from days to milliseconds. So 3 days times 24 hours, which is the number of hours in 1 day, times 60, which is the number of minutes in 1 hour, then times 60, which is the number of seconds in 1 minute, and then times 1000 to convert to milliseconds. And so now we get January 4th. So that's exactly 3 days later. Okay? And this number that we calculated here, that's actually calculated also here. So this is the timestamp. So we call this here a timestamp of the day number 3, essentially. And we will see why this is useful a little bit later. Now, these dates that we just created here are in fact just another special type of object. And so therefore, they have their own methods, just like arrays or maps or strings. And so we can use these methods to get or to set components of a date. All right. So working with dates here, and let's now actually create a date again. And this time we're going to store it in a variable. Let's call it future. So new date, and let's actually use the same as this one. Okay, just without the seconds, that's not really necessary. Okay, let's just log it to the console here to make sure. Okay, and let's, for now at least, just comment out these here. So we already know how it works. Now we just want to work a little bit with this particular date. So we can use future, which remember is simply this object here, and then the method get full year. And so indeed we get 2037. There's also get year, but never use that. Okay, always use get full year. Don't make the mistake of using that other one. Next up we have get month, and remember that this one is 0 based. So 10 is actually the month number 11. Then we have get date, and this is actually the day. So I think that this method has a little bit of a weird name. And so that's because get day is actually not the day of the month, but the day of the week. Okay, and 0 here is Sunday, and so 4 is the Thursday. So we saw already that it's Thursday, and so that's equivalent to number 4. And then besides these, we also have 3 more, which is get hour or hours, minutes, and seconds. So sometimes these can be pretty useful to work with a date. Besides that, we can also get a nicely formatted string. So basically similar to what we have up here, to ISO string. All right, so this is the ISO string, which follows some kind of international standard. And maybe you noticed that this is actually similar to the string that we used before, coming from account 1. So that's movement dates, right? So these were generated by exactly this method. And so that's one of the very useful cases, is when you want to convert a particular date object into a string that you can then store somewhere. Finally, we can also get the timestamp for the date. And remember that the timestamp is the milliseconds which have passed since January 1st, 1970. So get time. And so we see that this huge amount has passed, well, since that date. And now we can take this number and reverse this. So if we wanted, we could now create a new date only based on these milliseconds, and it would then give us exactly that same time. So you see, it's the same as this one, right? And so simply based on the milliseconds that have passed since January 1st, 1970. And timestamps are actually so important that there is a special method that we can use to get the timestamp for right now. So if you want simply the current timestamp for this exact moment, then you don't even need to create a new date. All we have to do is to call date.now. And that then gives us this timestamp. Okay. Finally, there are also the set versions of all of these methods. So let me just show you the one for the year. So I'm not going to go through all of them here. And so future.set full year. And this again is a method. So let's set it to 2040. And then we can take a look at our date. And so now it is November 19th, 2040. And of course, then the day of the month here has changed. And so yeah, there also exists set month, set date, set day, and so on and so forth. And these also perform autocorrection, just like here when we create a new date. Okay? So that's basically all the methods that you need to know about dates. And these last here are all quite intuitive, and all you need to know really is that there are all these different ways of creating dates. Now in the next video, we will then sum up what we just learned here to add dates to the Bankist application and make our project even better. Let's now implement dates in our application. And to see what we have to do, so where we have dates in our application, let's go to our demo here. And so we have the date first here, and then also in all of these movements. So each of them here, besides the deposit and the value itself, like we have it now, we also now need the date here. And so that's the reason why in our account objects, we actually now have the movement dates. It's so that we can display them here. But let's start with this date here. And actually the very first thing that I want to do is to basically fake it that we are always logged in. Okay, so let me do that here. Fake always logged in. And so this way we don't have to always log in each time we want to do something. So to that, let's set the current account to account 1. Then let's call update UI with that current account. And also we need to make the user interface visible with this here. Okay. So these 3 lines will now make it so that Jonas is automatically logged in, except for the message here, but that doesn't really matter. Okay. So as I was saying, let's start by displaying the current balance here. So as I was saying, let's now create this date here. Okay. And let's check out the class name. So that's as always a little bit hidden. So it's the class date. Okay. And so that is already selected at label date. And once more, let's start by setting this date outside here of any callback function so that we can see the effects as we implement our code. So anyway, let's start by creating the current date. And so remember, that is simply by doing new date. And so that is basically right now. However, we don't just want to print that. So let's see how that would look like. So label date, as I have already selected, which again is this element with the class of date. And then text content, and let's set it to now. And so this result here is not exactly what we want, right? So instead, we really only want the day, the month, and the year. And I want to display it in this format. So I want day, then month, and then year. And so this is how we display it in Europe, or at least in Portugal, where I am located. Okay. Now, of course, you can format it in any way that you want. For example, how it looks like in your country, but I will do it like this now. Now, later in this section, we will learn about something called internationalization, which sounds very complicated, but it will allow us to format dates and time according to the user's location, basically. So if the user was in Portugal, then the date would automatically be formatted this way. But if the user was, for example, in the US or in India or wherever, then the date would be formatted in the way that it is usually formatted in that country. All right? So to do this, we need to get the day, month, and year. So let's create variables for each of them. All right. So we take now, and then we call the getDate method, just like we learned in the last video. Then let's take the month, which is now.getMonth. And remember that this one is 0 based. So I'm going to add 1 here. And then the year, which is now.getFullYear. And actually, let's also get the hour and the minute so we can display that as well. So get hours and const the minutes. Get minutes. Okay. And now that we have that, all we have to do is to build a nice string with that. So that's the day slash the month slash the year. And then I want a comma and the hour and the minute. So min. All right. And that looks a lot better. Now, here in Portugal, whenever the month and the year is only 1 digit here, then we usually write 08 and 02. So basically, we pad this number here with a 0 on the left. All right. So let's do that with the day and with the month, because this is actually a good use case for this method that we studied earlier. So on the day and on the month, we want to use dot pad start. And actually, this needs to be a string now. And so let's make it a template literal. Like this. So basically, this is now a string. And so on that string, we can call pad start. And then we want this always to be 2 characters long. And we want to pad it with a 0. And probably just writing 0 would work just the same. And so now we get 02. But if the day would be, let's say, 12, then that 0 will not be added because the final length that we're looking for is always 2. Okay, and the same with the month. So let's copy it here. And beautiful. So that looks perfect. And now let's move on to actually use the dates here on the movements. Okay. just keep in mind that, of course, as the time goes on, this value here is not going to change. So this is static, right? So if we wanted to keep displaying the actual time, we would need something called a timer, which is something that we will do by the end of the lecture. We will not do it for this, but we will implement a timer like this. Maybe you have seen it counting down here. So this logout timer. All right, so this time here is going to stay static, but yeah, that's not a big deal for now. But anyway, let's now go to the function which displays these movements. So display movements. So here it is. All right. And so now besides the movements, we also want to display the times of these movements. But now we actually have a problem, because into this function, we are only passing the movements array itself, right? However, we also want the, let's see, we also want the movement dates. And so the best thing to do is to simply pass in the entire account into this function here as well. So just like we already have it in these two, where we already passed in the entire account, let's do the same here as well. So just the account. And then here we need to say account.movement and here account.movements. And finally, where we call this function, we then need to pass in also the entire account. And so that's here in the display UI function. Okay. And so now it is a good thing that we have this refactored function that we created in the last section, where we call all of these methods here only in one place. And so now we only needed to change calling this display movements function here in this one place. And so that's the whole goal of refactoring. It is making it easier to implement new features as time moves on. All right. So let's see how we could do that. So in here, we are looping over the movements. So that's this array that we compute here, which is whether the sorted movements or simply the movements themselves, right? So we are looping over this, and in each iteration, we are generating this HTML. And so now we simply need to add one more element here to this HTML, which is going to contain that date. So let's do that. So in our HTML, we can see that there is this element here called movements date. So let's copy that and paste it right here after the type. Okay. And so let's actually create a variable out here and then put that variable right here. Let's call it display date. Okay. Now, where is the date actually coming from? Well, as we already know, it is in the accounts.movement dates, right? And so here we are looping over the movements. And so at the same time, basically, we also need to loop over the movement dates. Okay. But that's not a problem because we already have the index here. And so what we can do is to write account or ACC dot movement dates, and then we take it at position I. So that is the current index in the movements array, and the same index is then going to point to the equivalent date in this movements date array. All right. So this is a common technique of looping over two arrays at the same time. So we call the for each method on one of them. So that's the movements. And then we use the current index to also get the data from some other array. Okay. And so that's going to be at the same position because we're using the same index. So let's create a new date out of this, because as we saw before, this is going to be a nicely formatted time string, right? And so we can use that string to create a new date object. And we need that object so that then from there we can call our usual methods to get the date and the month and the year. Okay, so that's the reason why we need to convert these strings back into a JavaScript object, because only then we can actually work with that data. And now let's actually create these same variables that we already have here. So there's no need to repeat it all. Let's actually get all of this and then delete what we don't need to make this a little bit faster. So we don't need the hour and the minute. So we don't need this. And we want to create this variable called display date. So the date that we're ultimately going to use here. Display date. And now here we need to change from now to date like this. All right. And we see it already worked. Great. So let's compare it actually here with the dates. So July 12, 2020. And yeah, that works. Here then we have 11, which for some reason is also 12. But I guess it's because we're close to midnight here. And so for some reason, probably it then changes over to the next day. Then here we have 27 of May. And so that's also what we get here, all the way to the last one, which is 18 of November, so 2019. So this is accurate. Great. Now, when we click here on the sort, it's probably not going to work. So we get some kind of error here. So cannot read property slice of undefined. Let's see why that is. Well, that's weird, because account.movements here is clearly defined. It shouldn't be undefined. Let's set this here to true by default. And so, well, now it is sorted. So very weird that we get this bug as we click here. Let's just log to the console. But indeed, this one here will be not undefined. But actually it now is undefined. So we get account.movements is undefined right now. And that's weird. But I guess it has something to do with the fact that we faked or log in here. So never mind. Let's take a look at this later. Okay, let's just not sort for now until we are back to having our application normal. All right. So actually, let's take this code here now and put it into the code that is executed when we log in. So besides this welcome message, we then also want to create the current date. Okay, so it's back to the original now. Let's now log in. And then we get the message here and the correct date. But now what I wanted to show you is what happens when we request a loan. So you see that we get this error here, right? And that's because this movement doesn't have any date, right? And that's why we get not a number in all the three values. So we need to fix that. So essentially, whenever there is a new transfer or a new loan, we need to not only push the new value into the movements array, but also into the movement dates. All right. So let's actually see that in code. So that's account 1. And so we see that the movements has now 9 elements, while the dates only has 8. All right. So we need to fix that. So let's come here to the transfer. And then besides doing the transfer and updating the UI, we also need to add transfer date. But that's easy enough. All we have to do is current account dot movement dates dot push, and then simply create the current date. So new date, and that's it. So JavaScript will then automatically convert this date here into a nicely formatted string. All right. And now the same here also for the receiver, because the receiver also gets a new movement here. Okay. And so they also need a new date for that movement. Now, as I told you also in the last section at the beginning of the project, in the real world, we would probably have an object for each movement. And so that object would then contain the amount, the date, and some other information about the movement. But I don't want to restructure the entire application now, and so therefore I simply created this separate movements dates array. All right. Now let's just take this here and also add it to the loan. So that's right here. So add loan date, and that should be it. So just to make sure here, let's really log in again. All right. And now I'm going to request this loan. And now we get the current date. So August 2nd, just as we have it up here. Okay. So let's see now the account. So account 1. Let's take a look at the movement dates. And so indeed, this is the one, or actually this is the one that I just added. So this looks a little bit different from these ones, because actually it is really the object itself. All right, so that's not good. So let's instead use the toISO string right here on the date and do the same also up here. Okay, and let's see if that fixes it then. Okay, so probably there was some error here because we're back to having not a number. And, oh, actually I need to take a look at account 1 now again. And so let's check out the latest date. Oh, and I didn't call the method. That was stupid. Actually, this is something that happens to me quite frequently with these date methods, because we don't have to pass anything in there. And so there's a tendency to forget that we even need to call the method. So don't make that same mistake. All right, and now it works indeed. So let's check if the string looks nice with the same format as all the others. And yeah, it does. And so with this, we finished one more lecture. Now here, I'm actually seeing something weird. So it's 19.1, but this should kind of be 0.1, shouldn't it? So we need to apply some padding to that as well. So that's a good coincidence that we are just at this time where I can see this. So let's go ahead quickly and fix that right here in the login callback. So that's here. And so essentially what we just need to do is to add this part to the hour and to the minute. So we make all of them a template literal again. And then like this. One more time. Okay, to see the effect, we need to log in. And beautiful. So that's a lot better. And now we indeed finished this lecture and are ready to move on to the next one, where we're going to work just a little bit more with dates. After adding dates to our app in the previous lecture, and in particular to the movements, we now have a huge bug in our app when we sort the movements in the user interface. And so let's now go ahead and fix that bug. Now, before getting to work, I just need to mention that I actually recorded this video after finishing this entire project. And so the code that you see here will be slightly different than what you have at this point. So for example, you're not going to have these two lines here yet in the display movements function, but that's not a big deal. You'll just have to keep that in mind as you progress through this section. All right. But anyway, let me now show you the bug, which is this. So as we click here on sort, these movements do indeed get sorted correctly. But watch what happens here to these dates. So the movement dates, as they're called. As you see, they stay in place. Now they move around here a little bit because these parts here correctly change. But this August 1st here, for example, will always stay here in the beginning, no matter what the value there is. So you see it's still the same date, but now with this different movement value. Now this happens because all we're doing here when we're sorting is to just sort the movements array, but not the dates, right? So here we are simply using the dates from the account object simply at the current index, but with no regard of sorting the movements. And so this is what we need to fix. So we need to basically sort these two at the same time. Now, I said in the previous lecture that in the real world, we would probably have an object for the movements, for example, containing the value of the movement, the date, and some other properties about this movement. And so let's now actually create an object like this here, basically combining movement and date so that we can then sort them both together. That's going to be the easiest way of doing this. We could also combine them into a nested array, but I think this way it's going to be a bit more explicit and easier to understand. Now, before we do that, let's actually also make sure, so you need to make sure that when you call this display movement, you actually pass in the entire account, because there was also some error about that earlier. So let me find that for you. Yeah, right here. So in display movements, you should not pass in the current account dot movements, but really the entire account. All right, so that's very important. And yeah, so here is the function. And so here, let's now create that combined movements with dates. So basically an array of objects where each of them contains the movement and the date, instead of having them like we have right now in a separate array for movements and one for the dates. So this doesn't make so much sense, but again, I'm not going to change the entire application architecture now, and so I'm just going to do that right here as we display the movements. So basically just temporarily, so that we can then easier sort them together. So let's call these here very explicitly combined movements and dates. And so here we just going to go over account.movements, and we want an array of the same length as the movements. So let's use a map here. And then in there, each of them is going to be called a movement. They actually also need the index. So we need parentheses here. So the index. And then here I want to return an object. And so we cannot just do this, but we actually need to wrap this into parentheses. Not sure if we ever did this earlier. We could also just create a function body like this and then return the object with whatever we want in here. So this would be the same as specifying parentheses here and then the object that we want to return. So here we want to return the current movement and then also the date. So let's specify a date property. And then this one is going to come from account. So the account that we're currently passing into this function, and then dot movement dates at the current index position. So let's use at and then y. All right. So again, here we are not doing the sorting yet. All we're doing is to create a new data structure in which we can then easily sort these two together. So let's log it to the console just to check it out. So let's find that here. And yeah, it has the same length. So it's again 8 for 8 movements. But now here it is called mov. Well, let's call this maybe movement. So movement, and then that's going to be the value of mov, because remember that this array here is just an array of these values. So checking this out again. So the movement is the value, and then we have the corresponding date. Nice. And so now we can just sort this object by the value here, and then the date will of course be sorted as well in the same order. All right. So now we're going to replace this part right here. For now, let's just comment this out, because of course we still need to make use of this sort property right here. But now we're going to do it in a different way. So here what we did was, if sort was true, then we would sort these movements here, and if not, then this value would just become the movements without the sorting. But now let's do it a bit differently. So now we already have the default, which is this one, and then all we do is to say if sort, and more like this. So if we should sort, then here we simply apply the sort to this array. Dot sort. And so this will then actually mutate the original array, which is not a problem in this case. But as you already know, if we don't want that, then we can use the toSorted method as well. But here, actually, this is exactly what we want. And so we're just going to take this array and sort it if sort is set to true. And if not, well, then it is simply this array right here that will be rendered in the next step. So let's get rid of this one right here and specify our sorter function. And so while earlier we had a minus b, because we already had the values here, because we were already sorting the movements array, now we need to, of course, grab that. So that's a dot movement minus b dot movement, because we still want to sort by those values. All right, so now, of course, mofs is no longer defined. And so let's fix that here in the next step. So we have now our data structures. We have it sorted if we want it. And now it is this data structure that we will actually loop over. So combined movement dates. And now we need to adapt this code here a little bit, of course. So here, instead of the movement, we get now an object. So let's call that object actually. And then here we can just destructure that. So we need to use the exact same name as the property names. So movement and date. And so this will then create these two variables out of object. And we could actually do this destructuring right here in this place, but let's keep it a bit more explicit by doing it like this. Now here we're creating a conflict with this variable right here. And so maybe let's call this here movement date. Okay, and then here we do the same. Movement date. And with this, we're fine. Now we just need to change the things here. So here we had mov before. So this is now called movement. Here we now have the actual date. So this was actually where the bug was coming from. And so now we will no longer read the date from the original array, but we will get it from the data structure that we just built. So that's then exactly that movement date right there. And then I believe that these two lines you will not have yet. And so again, as you go through the rest of the section, make sure that you use the correct values here. So this mov does no longer exist. So it will again be movement. And here I think everything is correct. So the date and the locale, and also down here. So let's try to reload this. So we have no more bugs. And now let's check if this actually works. So for example, here, this biggest value is on April 1st. So let's see what happens. And yeah, so now the date stayed together with the value. So let's unsort it. Let's just check another one. So this 642 is on May 8th. So let's sort and let's see if the date stays with it. So where is it? There, and nice. So with this, we fixed our bug. And we did so by always keeping the date together with the movement value itself, simply by creating this combined data structure right here. So let's just get rid of this. And yeah, I think now you're ready to move on to the next lecture. Again, just keep in mind that you will have to use this movement here instead of what I'm going to type in that video. In that video, I will just type out this, but that is now wrong. It needs to be movement now in order to work. Let's now perform some operations with dates. So one cool thing that we can do with dates is to do calculations with them. For example, we can subtract one date from another date in order to calculate how many days have passed between the two dates. And this works because whenever we attempt to convert a date to a number, then the result is going to be the timestamp in milliseconds. And with these milliseconds, we can then perform calculations. So again, the timestamps are going to be really helpful here in this situation. So let's get this date here. Okay, and let me just demonstrate what I just said. So I will convert to a number this future. So you see, it worked. And the same thing is going to happen when I use the plus operator on it. So you see, and so in fact, that does mean we can now do operations with it. So if we subtract one date from another, the result is going to be a number like this, so a timestamp in milliseconds, and then we can simply convert these milliseconds back to days, or to hours, or to whatever we really want. So let's actually now create a function that takes in two dates, and it's going to return the number of days that pass between these two dates. So days passed is going to be a function, or let's use an arrow function. So a nice one-liner. So date 1 and date 2. And then all we need to do is date 2 minus date 1. And so let's suppose that date 2 is later. But in case we do not want to suppose that, we can simply take the absolute value here. And then it doesn't matter which of the dates here happened first in time. But for now, let's keep it like this so I can show you later what I mean. So for now, let's actually also return this result. And then I will just call this function here. So calc, or actually it's just called, well, it should be called calc. So this looks a bit nicer. So calc days passed. And then let's just create two dates here. So let's use this one here. Maybe make it a little bit simpler. Let's say here, April 14th. So this is the first date, the first that happens in time. And then the second date, let's just say, well, April 24th. So this then makes it easy for us to visualize the result. And let's just call this const days 1 and then log it to the console. All right. And so this gives us these milliseconds. And so now we just need to convert them. And this is similar to what we did, I think, in one of the previous lectures. So we want to divide by 1000. And so this converts milliseconds to seconds. Then that times 60 to convert it to minutes. Then times 60 to convert it to hours. And then times 24, which converts it to days. And again, that's because there are 24 hours in a day. There are 60 minutes in 1 hour, 60 seconds in 1 minute, and 1000 milliseconds in 1 second. And so now we get 10 days. And that makes sense, right? So from April 24 to April 14, we have exactly 10 days. Now what if here we pass 4? So now it's going to be the other way around, right? So now we have minus 10, but we don't want that. We always want it to be 4. And so that's what I meant earlier, where we can now simply take the absolute value of this. So math.absolute. Which of the dates we pass in first. So if we now put 4 here and 14 here, then the result is still going to be 10. Great. So this works just really nice. Now, if you need really precise calculations, for example, including time changes due to daylight saving changes and other weird edge cases like that, then you should use a date library like moment.js. And that's a library that's available for free for all JavaScript developers. But for something simple like this, we should be fine. Now let's just consider that one of these days here also has some time. So let's say in this one here, it's also 10 in the morning or 10 hours and 8 minutes. Doesn't really matter. But let's see what happens to the days now. And so indeed, we now get 10.4. So we might not want that. And in this case, we can simply use math.round on all of this. Okay, so keep that in mind. But I will just leave it like this. All right. And now let's actually use this function to format and display our dates in a little bit nicer way here in our application. So basically what I want to do is if one movement happened today, then here instead of the current date, I want to display today. Then if it happened yesterday, I want to write yesterday. And then if it happened like a couple of days ago, then I want this to say like 2 days ago or 5 days ago instead of the date. And I'm sure you have seen this kind of stuff in many web applications that you use in your daily life. For example, if you post something on Facebook, and if you then watch it the next day, it will say that you posted it yesterday. It's not going to display the exact date if it was just yesterday. And so that's a really nice use case of using a function like this. So let's grab this here. So I'm copying it. And then let's go to the display movements function where we do actually print the date. Now this is all kind of getting out of hand. So we have a lot of extra code here. And now we will add even more. So this function here and even some more stuff. And so let's take all of this here and actually create a new function which will have the purpose of formatting this. All right. So let's cut this here, as I just said, and create a function up here just to make it a little bit more modular. All right. And then we could also reuse this function in some other place, even though right now, in this case, we don't need it. I'm just doing this to split up the functionality a little bit across different places in our code. Okay. So this one receives a date as an input, and it will return the formatted date then. Okay. So I'm copying all of this, but actually this one should stay back here where we got it from. And then also, so this, we need this variable back here where it came from. So display date, because we use it down here as the value that we eventually want to print to the user interface. And so this one should actually be the result of calling our new function. So this format movement date. So format movement date, and here we pass in the date variable that we just created up here. All right. And so with this, we just exported the functionality here into a new function. So let's grab this and put it here at the top of the scope. And so for now, just to keep this working, let's return then this value. All right. And as you see, and let's just make sure by logging in. So as you see, the dates are now still being correctly printed. So we successfully exported this functionality here of displaying the dates into this function. And now we can just implement what I just said. So basically calculating how many days passed since the current date and between the date that we are working with. All right. So let's say const days passed and between. So between right now, that is new date. And then the second date is the date that we just received here. So let's just print this to the console to see if it works. Okay. So what's all of this here? So we are printing here actually the wrong thing. So we want days passed. So that was a mistake, obviously. But it's still not correct. And okay, I have another mistake. So probably you saw this already. So I did not even call the calc days passed function. But now it should be good. And indeed, now we have our days here. All right. And now let's actually round them. Okay, so that's what I was just saying earlier, so that we should probably round these dates. So we already learned how to do that. So math.round all of this. And so this looks a lot better now. Now let's actually modify our dates here a little bit. And you should do the same. And what I'm going to do is to make one date yesterday. And then also a date like 3 or 4 days ago. So see what's your current date and then simply subtract 1. So for me, it's August 2nd. So I'm going to use August 1st. And then also July 28th. And maybe another July here, 25 or maybe 26. Okay, it's just so that we can see like the yesterday or 3 days ago or something like that. All right, so do that now. And then let's go back here to our function. And then we want to implement some logic based on this day passed. So if days passed is 0, and so basically that is if we do something today, then actually the string that we want to print is not the current date, but instead today. All right. Then if 1 day has passed, we want to return yesterday. Okay. Next up, if, well, let's say if the number of days passed is within the last week. So that's less or equal 7. And then we will return the number of days. So days passed, days ago, and else. So only if more than 7 days have passed, only then we want to return the actual date. Okay, does that make sense? So let's save and see if it works. And yes, beautiful. So that's yesterday, 5 days ago, 7 days ago. And then here the other dates right here. So that's beautiful, great. Let's now just do something. And actually let's transfer like 500 to Jessica Davis. And that's going to be the other way around. Jessica Davis 500. And so now we should get one log here with today. Yes, indeed, there is today. And now if we log in as Jessica Davis, we should get the same. So now we have a deposit coming from today. And actually, we also have something from 7 days ago. So, great. That's amazing if you ask me, that we are capable of now doing something like this, which looks like a real web application that you might use every day. All right. Now, maybe the logic here is a bit confusing with all of these returns, but that's completely normal. So as you know, once we return, the function stops executing. And so these other returns will then never be reached. And so this is a pretty common technique. And actually, we wouldn't even need this else. So if I just remove this here, then all of this code will only be executed if all of these here are not executed. So only if all of these here are false, the rest of the code is even executed. So you see it works the exact same way. Awesome. So our application is even better now. And in the next 2 lectures, we will then do what I mentioned earlier, which is internationalization, which is to basically format these dates and also these numbers here according to each of the countries of these accounts. So JavaScript has a new internationalization API. Now that sounds very fancy, but all it does is to allow us to easily format numbers and strings according to different languages. So with this new API, we can make our application support different languages for users around the world, which is pretty important. For example, currencies or dates are represented in a completely different way in Europe or in the US or in Asia, for example. Now, there is a lot of language-specific things that we can do with the internationalization API. But in this section, we're just briefly going to talk about formatting dates and numbers. And starting with dates in this video. So in our application, we have dates in 2 places. First right here, and then second here in each of these movements. Now, in case you're wondering why these labels like today or yesterday or 5 days ago are gone here from my application, it's just because I'm recording this video a couple of days later. All right. But anyway, let's go to the place in our code which displays this first date here, so that we can format that according to different languages and see what it looks like. And so that is right here in the login handler function. And in particular, this is the code that we have currently. Remember doing this? But now we will actually be able to get rid of all of this and simply replace it with the internationalization API. So it will do this kind of formatting for us automatically. But for now, let's actually display this date here outside of the login so that we can experiment a little bit with this API without having to log in all the time. So I will grab the current date, experimenting with the API. Okay. And then we also need to get just this part where we do then actually display something in the DOM, right? So we want to set this text content property here to something. And we want to set it to a formatted date. And so let's now use the internationalization API for that. So that's new. And then Intl. And so that's basically the namespace for the internationalization API. And then for times and dates, we use the .date time format function. Okay. Now all that we need to pass into this function here is a so-called local string. And this local is usually the language and then dash the country. So something like this. So English and then dash US, for example. All right. And so all of this here will create a so-called formatter for this language in this country. So English.us. And I will show you a list of many different locales here in a second, but for now let's get started with this one. So all of this creates a new formatter, and then on that formatter we can call .format. All right, and then here we actually pass in the date that we want to format. So that's now. And that's actually it. So let's reload here. And you see that now the date is actually formatted just like it is usually formatted in the US, with the month first and then the day. Now English is also spoken in other languages. So let's try the UK now, or Great Britain. So for the UK, we have to use this one. And now you see that it is different. So you have the day first, then the month, and it also has this leading 0 here. And so you see that now it is actually formatting this date for this exact locale that we specified here. And so just with this one line of code, we have correctly formatted the date for any user around the world. And let's try some other countries here as well. For example, we could try Arabic for Syria. So that would look like this. So in these symbols that I cannot really understand, but what matters is that it is indeed formatted correctly. Let's just put it back here. All right. And to get these different codes, let's just Google ISO language code table. And then the one that's easiest to understand is this one here. So go to the one that has lingos.net, and then from there you can find your own code and then experiment with that and see if it's also correct. All right. Now this is the most straightforward way of formatting dates and times, but we can actually take it to the next level and add some options to also customize this a little bit. For example, you see that right now it only displays the date here, but not any time, right? And so we can change that by providing an options object to this function here. So let's define that options object outside here. And I'm simply calling it options. And so all we have to do is to specify the hours property, or hour, and set it to numeric. And the same for the minute, set it to numeric as well. And now we have to then provide this object here as a second argument into the date time format function. So options. And of course we could have written this object right here, but I will add some more stuff to it in a second. And then this line of code here becomes a little bit messy. So it's quite usual to have a configuration object like this one here defined outside. So, as you see, now we get indeed the time. But on the other hand, now the date is gone. So let's get that back as well. And here we can specify properties for each of weekday, year, month, and day. So let's start with the day, and I will set it to numeric as well. So let's see what happens then. And so now we only get the day. Let's add the month as well. Numeric again. And so now we get the month here as 8. Okay, and that's because we specified it as numeric. But for month, we can also write long. So let's see what happens then. And so now we get August, and so not just the number. And for the month, there is even another option, which is 2-digit. And so then it would be 08. But let's leave it at long. And now the year as well. Let's set it to numeric. And of course in quotes. All right. So that's 2020. But we could also say just 2-digit. And so then it would be 20. But again, let's leave it as numeric. And finally, we can even specify the weekday. And here I'm using long again. And so then it will write out the day completely. So Wednesday, August 12, 2020, and all of this nicely formatted, just like people in the US do it. All right. Now here we can also say short or narrow, and you can experiment with that. So let's see what it would look like in the UK. So that's pretty similar. But now let's see, for example, Portugal. So PT-PT. And so now you will see this here, of course, written all in Portuguese. And the same, of course, for other locales, so for other languages. Now, in many situations, it actually makes more sense to not define the locale manually, but instead to simply get it from the user's browser. And so that's pretty easy to do as well. So let's define another variable here outside. So locale, and then that's simply navigator dot language. So let's log it here to the console first. So you see that mine here is set to English, Great Britain. And so if I replace this here now, then you will see that it will go back here to displaying it in English. All right. And so if you do this yourself now, then your date should be displayed to whatever language you have in your browser. Anyway, let's now take this and actually put it here into our login. So replacing all of this, I will just comment it out to leave it here. And now we have a duplicate here. Let's get rid of that. So now the date will only get formatted when the user actually logs in. All right. But now let's take a look at our account objects here. And so you see that now in each of the accounts, I defined a locale, right? So account 1 is Portuguese and the other one is in English. And so let's now actually use these locales to display Jonas's date here in the Portuguese format and Jessica's date in the American format. Okay, so that's easy enough. We just have to find the correct place in our code. So yeah, that's right here. And remember that we have the account in the current account variable. And so here, instead of using this locale that's coming from the browser, so instead of using this, we use current account.locale. So let's give it a save. And now I will log in as Jonas. And remember that should now display in the Portuguese format. And indeed, it does. Now the problem here is that our entire user interface is in English, but now I have this weekday here in Portuguese and also this month name. So to fix that, let's actually set the month here back to numeric and also get entirely rid of the weekday. So let's try that again. So we got rid of the Portuguese words here, but the formatting still follows the official Portuguese way. Now let's check out Jessica Davis. And so you see it looks different now. It is now in the American format with the month first and then also with the AM time down here. And of course you can set one of these accounts to your own language to see how it would look like in your language to make it a little bit more personalized for yourself. Great. So with this we have localized this date here. Now we need to do the same with the dates down here in the movements. So let's go to that function which formats these dates. Remember we created a function for that up here. So that is format movement date. Okay, again, let's now do this formatting here also for these movements. And so what we're going to do is to replace all of this here with a new nicely formatted date. So instead of returning all of this here like we did before, we will simply return new, and then again the intl namespace, date time format, and then here we need the locale, and so let's actually pass that into the function. All right, so this function right now only receives a date, but we also now need a locale. So let's add that here as a second parameter. And now wherever we call this function, and that is down here, so here we now need to pass in that locale, of course. And so that comes from the account.locale. So the current account in here is called ACC, remember? And so that locale is at acc.locale. All right. So return new date format, and then simply the locale that we receive here, and then format the date. And so that's again the date that we receive as an input here. Okay, and that's it. And in this case, we don't want any options object because here we don't need the hours or the minutes. All we want is to simply display the date as simple as possible. And in that case, we don't even need any options. So let's give it a save here. Try it now with Jessica Davis. And you see that indeed, now it is the American format with the month first like this. Let's just transfer some money here to Jonas. And so of course here our today still works. So these kind of easier to read and understand labels that I showed you earlier. So that is the American format. And now let's again see Jonas format, which should now change to the Portuguese one. And indeed, it did. And so this part is now working as well. Great. So in a nutshell, this is how we localize dates in JavaScript using the new internationalization API. And as always, feel free to read the documentation on MDN. So that's just MDN intl. And so here you're going to find all kinds of different functions. So I mentioned in the beginning that there's all kinds of stuff we can do with this API. So besides dates, so we can also format lists or like words and their plurals. All right. But if you want to learn about this one a little bit better that we just used, you can go ahead and read the documentation right here. In the next video, we will use this number format function here to format all the remaining numbers that we have in our application. So let's move on and do that now. So in the last video, we formatted dates using the internationalization API. So now let's actually format regular numbers. And let's start by doing some experiments in the console first before we move on to our application. So I'm just defining some number here. It doesn't really matter which one, just so we can experiment with it a little bit. Okay, so let's do the most basic formatting now, simply doing new, and then again, this intl namespace. And now this time we use number format. And so this again takes in a local string. And so let's experiment with the US. Okay. And so all of this here creates a formatter. And then one more time on that, we can call the format method, where we then pass in what we actually want to format. And so that is this number. Let's just also log here to the console that this is about the US, so that we can then have some other locales as well. Okay, so you see that the number is now formatted using these dividers here. So these commas here as separators, so that it's easier to read 3,884,000 and so on. But let's see how it works in other countries. So in Germany, for example, it is different. Let's add some spaces here. Okay. And so here we want like this. And since we're doing this, let's try some other countries here as well. Let's just say Syria. Why not? So the one that I used earlier as well. So that is Arabic, and then the country is SY. And you see that in Germany, as in general in Europe, the separator is the dot, and then a comma for the decimal part. So basically just the opposite as it is in the US, as you see here. And then for Syria, well, it's even more different. I cannot even read this, of course. And of course, we can also just use the locale from the browser. So that would be navigator.language. And actually, let's log that here. And so, yeah, in the UK, it's basically the same as in the US. So again, this is just the most basic formatting, but let's now define an object here. So again, options for this formatting. But of course, now we have other properties in this object. It's no longer day or month or something like this, but instead we can specify the style, for example. And here we can say that this is a unit, and then we can set the unit property to something. And let's say mile per hour. And there are tons of units like this. And so as always, you can read more about the units that are available in the documentation. But let's see what happens now. No, but apparently nothing happens. Now we just need to pass in this options here, of course, into the number format function. So again, as a second argument, and let's do that here in all of the 4 at the same time, using these multiple cursors. And let's give it a save. And indeed, now we get this unit here. And one more time, you see that it's written differently in the US or in Germany, for example, or in Europe in general. And you see in Syria or in Arabic, apparently this is how you write miles per hour. Okay. But of course we can try others. For example, for temperatures, there is Celsius. And so indeed, we get degrees Celsius. So that is for units, but we can also say percent, and then the unit is completely ignored. So we get the percentage sign, and again it is different in different countries. So here we have this space. And then there's also currency. So these are the 3 different options for the style. So that's unit, percent, or currency. And again, if we have a currency, then the unit is just completely ignored. But we do have to then define the currency. So let's say euro, and for that, it is like this. So EUR. And so if we give it a save, then we get indeed the euro sign. And so here in Europe, it comes after the number, and in the US, it comes before the number. And it's important to understand that we do indeed have to set this currency here, because the currency is not determined by the locale. Okay, so it's not defined by the country here, because it's of course possible to show, for example, euros in the US. All right. And so, of course, we have to define the currency here manually. So it's not going to be implied from the locale string. Okay. Finally, we can also turn off or on the grouping. So let's use grouping and let's experiment with false. And then you see that the number is just printed as it is without the separators, so the grouping. But let's get rid of this one here. And again, if you're interested in even more properties that you can set here in the options, then just check out the documentation here on MDN. Okay, but now what we're going to do is to actually use this knowledge and implement currencies here in our application. So let's move up here, and I'm going to start here in the movements. So where is that function? Now you see we have a lot of code here already, and in the real world we then split up all this code into different files, okay? Because as it is right now, it is indeed a little bit messy, but for now it is just okay as we have it. Now, anyway, right now we are displaying the currency here in these movements right here. So we convert everything to 2 decimal places, and then we display the euro sign here ourselves. But now we want the internationalization API to take care of all of this. So let's create a variable out here so that we don't have to do all that formatting here in the template literal. So we do it outside here. So let's call it formatted movement. And then again, we use new and then number format. And now you already know that we have the locale right in the account object. And so that's again ACC, right? So just as we did here for formatting the date, we use acc.locale. And then we also need an options object. And this time, let's actually write that object right here. So we need to set the style to currency. And then we need to define the currency property. So just as we did earlier in this video. And let's just experiment a little bit here. Let's say that we want US dollars instead of euros. Okay. And so now here we can get rid of all of this, including the euro sign, and now simply use this value. So formatted movement. Okay, give it a save. And now we need to, of course, log in here. But before doing that, I see already that we have some problem here with this object. And the problem is that we here didn't even call the format method. So all we did was to define this variable here as number format. And so that's then this formatter, remember. But on that, we then need to actually call the format method. And so this is where we pass in the value that should be formatted. And that is simply the current movement. So this mov value here. So if I save it now, then that should be fixed. And indeed, you already see US dollars right here. But anyway, let's log in as Jonas now. And yeah, everything is US dollars. However, the number itself here is of course still formatted in the Portuguese way. So that's the current locale of the current user. Remember? So that's Jonas, and the locale is PT. Remember? And so therefore, the number is still formatted in that way and not in an American way. That's only for the currency. Okay? So that's USD, but the rest is still according to the user's locale. So that's what I said earlier, that the currency is completely independent from the locale itself. So in this case, we have a European country with an American currency. All right. Now, indeed, we also have the currency in the accounts object. So we have the locale and also the currency. And so let's now get that currency also from the account itself. So that's right here. And so here we actually want account dot currency. So if I load it now, then indeed we get euros. All right. And if I log in as Jessica Davis, which has USD as the currency, then we get the dollars, and we get it also formatted in the American way. Because for Jessica Davis, the locale is also it is English in the US. And so this is what it looks like here, formatted for the US with US dollars. Of course, we could change this to euros, and then, of course, now we would have the euro sign. All right. So one more time, you can see how powerful this is and how easy it makes formatting for us developers. Okay. Now, anyway, that is the movements, but now we also have the currency in a lot of other places. For example, here in the balance, and then also down here in these statistics. So let's start to also implement the same formatting here in the balance. And so that is, that's right here. Okay, so here we also have this old way, basically, of formatting, but we know that we can do better. So we can now go ahead and grab all of this like this and paste it here and then use this. Okay. However, as you can guess, that is not a good practice because we are repeating the don't repeat yourself principle. Right? So let's get rid of this. And as you can guess, we will create a new function here, which will take care of formatting the currencies. So let's call it format cur, which stands for currency. So a new function. And let's create a very reusable function here. So instead of passing a whole account object into this function, which is very specific, of course, to this exact application, let's do a function that you could use in any other application. So basically a function that is less dependent on the underlying application data. Okay, and so instead, what we will do is to simply pass in all the data that this function needs to work with. So that's the value, the locale, and the currency. Okay, so again, we could pass the entire account object here instead of these two, but here we just want to do a reusable function. And so this is a lot better for that. All right, so this is the code that we had written earlier. And here we don't even need to create a new variable. All we will do is to return the result of this number format function. Now we just need to adapt this a little bit. So here it's just the locale that we get in here as an argument. And then here the same for the currency. And what we want to format is the value that we get in. All right. So again, a nice and simple reusable function that can take any value, any locale, and any currency, and will then return this value here nicely formatted for that locale and currency. So let's use that here. So of course, instead of what we had before, formatted mov will now become format the currency, and then the value is mov, the locale, which I think is the second one. Yeah, it is. So it's very handy, again, here in VS Code to just hover over the function name. So the locale is at account.locale and the currency at account.currency. And so we can get rid of this. Now I will just copy this part here. And so now what we want to format is account.balance. Okay. And we actually don't even have to store it into a separate variable first. We can just take this result directly and then display it as a text content here in our application. So if I log in now as Jonas, then this should already be nicely formatted, and indeed it is. So we see we have this nice separator here, which makes our number easier to read. And now as Jessica Davis, it should be the American separator, so with the comma here. Okay, so that's great. All that's left now is these three values down here. All right, but that should be easy enough with the function that we already created. So let's just copy it here. And then we simply basically need to paste it here to these three places. So here it is the incomes that we want to format, right? So incomes. Then here it is this part here. So the absolute value of the out. And then finally down here, it is the interest. Now I copied that code from earlier. So again, it is this interest that we want to format now. So interest. And indeed, you can already see, even without logging in, that it worked down here. So we have this nice separator here indeed. And so if we log in again with Jessica Davis to see it as US dollars, then we get this nice result here as well. Beautiful. And actually, that's it for the internationalization API. That's all I had to show you. But as I told you right in the beginning, there is a lot more potential in this API. To finish this section, let's quickly talk about timers in JavaScript. And we have two kinds of timers. First, the setTimeout timer runs just once after a defined time, while the setInterval timer keeps running basically forever until we stop it. So basically, we can use setTimeout to execute some code at some point in the future. So let's use this to simulate ordering a pizza. So when we order a pizza, it doesn't arrive right away, right? So instead, it's going to take some time, and we can simulate that. So let's write setTimeout, and then this function receives a callback function. So just like some array methods or DOM event handlers, right? And we already talked a lot about this, and I think we even used the setTimeout function here as an example of callback functions a bit earlier, right? So let's use an arrow function this time, actually. Because why not? And so here, let's just say, here is your pizza. And then just some pizza emoji here, maybe. All right. So this callback function here is the first argument of the setTimeout function. And so again, we do not call this function ourselves. We simply pass in this function as an argument to setTimeout. And it is this function who will then call our callback function in the future. And when does that future arrive? Well, that's what we specify here in the second argument. So here we pass in the amount of milliseconds that will pass until this function is called. So let's say we want to call this function after 3 seconds, and so we need to pass 3000. So 1 second is 1,000 milliseconds. And so this is basically 3 times 1,000. Okay, so let's give it a save. And you see the page reloaded. And now, after 3 seconds have passed, we get this log to the console. Okay, and so with this, we really delayed calling this function here, right, by exactly 3 seconds. And we can also say that we schedule this function call for 3 seconds later. All right. Now, what's really important to realize here is that the code execution does not stop here at this point. All right. So when the execution of our code reaches this point, it will simply call the setTimeout function. It will then essentially register this callback function here to be called later, and then the code execution simply continues. And we can prove that by doing something after the setTimeout. So let's say waiting. And if we now save this, then immediately we will see this waiting in the console. So let's check that. And indeed, we get waiting. And then after the 3 seconds, then this log here appeared. All right, so this is really important to understand. So again, as soon as JavaScript hits this line of code here, it will simply basically keep counting the time in the background and register this callback function to be called after that time has elapsed. And then immediately JavaScript will move on to the next line, which is this one. All right. And this mechanism is called asynchronous JavaScript. And we will talk about how exactly all of this works behind the scenes in a special section just about asynchronous JavaScript. Okay, but anyway, what if we now needed to pass some arguments into this function here? It's not that simple, right? Because we are not calling this function ourselves. So we are not using the parentheses like this, and so therefore we cannot pass in any arguments into the function. Right? Now, however, the setTimeout function here actually has a solution for that. And it works like this. So basically all the arguments here that we pass after the delay will be arguments to the function. So let me demonstrate that to you. So let's say here olives, and then another argument, spinach. And so here I can now specify the ingredients. So olives and spinach will be ingredients in our pizza. So let's say ingredient 1 and ingredient 2. And here we can then use them somehow. Let's make this a template literal. Let's give it a save here. And so the waiting once again appeared immediately. And then after 3 seconds, our string appeared logged to the console. And indeed, this third argument that we passed in did now become the first argument or the first parameter of our function here. And then the fourth argument became this second one. And if we passed in even more, we could then get access to them here in this callback function. All right. And that is essentially how the setTimeout function here works. There's just one more detail that I want to show you, which is the fact that we can actually cancel the timer at least until the delay has actually passed. So before these 3 seconds here have passed, we can cancel the timeout. And so let me show you how. Now to build this example, I first want to change something here. So I want to put the ingredients into an array. So let's say, again, olives and spinach. And so how would we then pass in these ingredients here? We're not going to do ingredients 0 and ingredients 1 like this, right? No. Instead, we will spread the array here using the spread operator. And so this will then take the elements out of the array and put them here basically comma separated. And so this now works exactly the same. But now what I want to do here is to say that if the ingredients include spinach, because that's something that many people don't like, so if the ingredients include spinach, then clear timeout. And so now here we need to pass in the name of the timer. And so we can basically assign this timer to a variable. So let's say simply, let's say pizza timer. And so here we can then use that variable, so that timer, to clear it. All right. So again, here we basically stored the result of the setTimeout function, which is essentially the timer. And then we can use that variable to clear the timeout. And then we can use that variable to basically delete the timer. And for that, we use clear timeout. And so now, since this array contains this spinach here, now you will not see the pizza string here printed to the console. All right. But if it did not include spinach, then of course, it would still work after 3 seconds. All right. So this is how the setTimeout function works. And that's actually it. That's all you need to know about the setTimeout function. It's pretty straightforward, right? So let's now actually go back to our application and implement a timer to simulate the approval of our loan. Okay. So when we click this button here to request a loan, then we get the value immediately right now. But typically a bank takes some time, like some days or some weeks, to approve that loan. And so let's simulate that here by taking like 2 or 3 seconds. So what happens when we successfully request a loan is essentially this code here, right? And so let's simply wrap all this code into a function. So curly braces, then function just like this, and then put all of this into a setTimeout. And then down here, give it a save, and then it should be nicely formatted. Okay, and now let's say, well, after 2.5 seconds. Okay, and so let's just see what it looks like in practice. So requesting a loan of 1,000. And so now it's going to take 2.5 seconds. And indeed, the bank just approved my loan here. So that was 10,000. Let's do something else. So count the seconds here. And now my loan was approved. And so then it appeared here in the movements, and it also appeared here in the balance. You saw that? So that makes our application a little bit more realistic. But let's go back now, because we also need to talk about setInterval. So we learned that setTimeout here simply schedules a function to run after a certain amount of time. But the callback function is only executed once. Now, what if we wanted to run a function over and over again, like every 5 seconds or every 10 minutes? Well, for that, we have the setTimeout function. So this one is going to be setTimeout. So let's use the setTimeout function to basically create a clock that will display in our console. So setTimeout, and then a function. And of course, I could have used an arrow function, but it doesn't really matter here. So our callback function, and let's create a new date here. So let's say now, and then new date. Okay, so this is nothing new at this point. And then let's just log that date, so that current date, to the console. And we want to execute this every 1 second. And so here we say 1 second. So let's see what happens. And indeed, once every second now this should be executed. But it doesn't. And that's because I made the mistake of calling setTimeout again. But of course, as I was saying all the time, this one is actually called setInterval. So maybe you were already spotting this mistake, but now let's see what happens. So now, after each second here, we get the current time displayed to the console. So what's happening here is that this callback function is now executing every second. Okay? So every second a new date is created here and is then logged to the console. And of course, we could also say every 3 seconds. And then we would get the current time on the console every 3 seconds. You see? So it's adding 3 seconds each time now. But 1 second here makes a little bit more sense. Now, of course, you could print a real clock using this function now. Like you could get the current hour, minutes, and seconds from this now date. And so I would challenge you to do that actually, to take a minute or two in order to build like a real clock that is only logging the hours, minutes, and seconds here to the console. Now, I'm not going to do that here, but I think this would be a nice challenge to train a little bit the stuff that we've been using previously in the section. But for now, this is actually enough for this video. So take this challenge that I just mentioned, and then I'll see you soon in the next video. Welcome back. And this is going to be the last part of this project. So we're almost done here. Now, for security reasons, real bank applications will log out users after some inactive time. For example, after 5 minutes without doing anything. And that's what we will implement in this video using the setInterval timer. And let's start with one final look at our flowchart. So the timer appears in multiple places here, and the first one is right here. So whenever the user logs in, the logout timer will start or restart. All right. And then as soon as the logout timer expires, which will be after like 5 or 10 minutes, then we want to log the user out. All right. So basically that's what we will do with the timer, but let's start very simple. So the place where we want the timer is here in this function about the login. Okay, so this here is the handler function that handles the login. And so our timer will start here. Now we already have plenty of code here, as you see, right? And therefore, let's actually create a separate function which will start this logout timer. All right. So let's say start logout timer. And this function doesn't need any arguments. All it does is to basically export some functionality into an external function. So let's write some pseudocode here, basically by writing some comments to say what exactly we are going to do here. So we will start by setting the time to, let's say, 5 minutes. Okay. Then we want to call the timer every second. Then in each call, so in each callback call, print the remaining time to the user interface. And then when the time is at 0, so after the timer basically expired, so when we reach 0 seconds, stop timer and log out user. Okay. And to make this a bit easier to visualize, let's go again here to our demo application. And so the timer that I mean is this one here, which actually starts at 10 minutes. And you see that after each second, a new time is basically printed here. All right. And I'm not going to wait for 10 minutes now, but when this reaches 0, then the user will, of course, be logged out. Okay. So let's basically do everything that we described here. So I'm setting the time for now just to 10 seconds. Okay, just so we see what's going on. Or actually, let's say 100 seconds, so that we have actually more than 1 minute. Then we want to call the timer every second. So basically what this means is to use the setInterval function and then pass in a callback function, and this callback will be executed every second. And so 1000 milliseconds here. All right. Then each time that this function is called, print the remaining time to the user interface. And then this one here as well. So when we're at 0 seconds, stop the timer and log the user out. So we want to print the time here to this label, which is called label timer. So let me just show it to you here in our elements that I pre-selected. So label timer is the element with the selector of simply timer. Okay. So let's go. So label timer dot text content is equal to the time. And so that's this here. So I forgot to write the name of the variable actually. And now to make this actually work, we also need to remove 1 second in each of these function calls, right? So decrease 1 second. And so time equal time minus 1, which is essentially the same as saying time minus minus. All right. So this is the logic of this timer. We start with a certain number of seconds. Right now that's 100. And then each time that this callback function here is called, we remove 1 second from that. Okay. And so this is called every second. And so basically we will end up with a timer which shows the current number of seconds each second. Okay. And now all we need to do is to then call this function here on login. So, well, let's do that here before updating the UI. So start, logout timer. And now let's quickly log in here. And indeed, you see this number here decreasing now. Okay, so hopefully that that logic makes sense of decreasing 1 second every second. Now, where is that? We have too many functions here, I guess. Oh, here we go. So again, the logic here is to decrease the timer by 1 second every second. And so therefore, we get this number here going down by exactly 1 each second. All right. Now, we don't really want to see only the seconds. We want to see the minutes as well. So basically, we need to convert this simple number of seconds to minutes and seconds. All right. So let's do that here as well. So let's say the minutes is the current time divided by 60. So that's the easiest way, basically, of writing it. So it's not going to be correct, but it's going to show us what we need to do next. Now here we're also seeing already what happens with this timer after a certain number of seconds. So indeed, as soon as the time hits 0, it will not simply stop, right? We're not telling the timer anywhere to stop. And so it will simply continue and become negative. And so that's what we will have to implement then down here. But let's leave that for later. For now, we just want to display the number here in minutes and seconds. But for now, I will just show you the minutes, just to show you what we need to do next. So you see that we have 1 minute, 0.6 or 0.5 something. So it's decreasing every second, but this number here after the comma or after this period doesn't really make sense, right? So basically what we want to do is to take whatever remains of dividing the time by 60, because that will be our seconds. So let me show that to you as well. So seconds will be the remainder of dividing time by 60. And so that's where, again, the reminder function is very helpful. So the reminder operator, actually. So let's now print both of them here as a template literal. So minutes, and then colon the second. Okay, and this is still far from being complete, but let's take it step by step here. So you see that this number here is now decreasing very nicely, and it started at 1 minute and 40 seconds. And that's exactly what 40 seconds is, right? So let's do this again, actually. And notice down there how it starts exactly at 1:40. So you saw that? And that 40 appeared because that is the reminder of dividing 100 by 60. So let's see it here in the console. So when we divide 100 by 60, then this is the result. But if we do 100, the remainder, then we get 40. All right? And that's because 1 times 60 plus 40 is then again 100. All right? Now here we actually do not want then this value after the comma, right? We are only interested in basically the integer. And so let's cut off that decimal part by saying math.trunc, all of this here. And then we also want to pad this number here with a 0. So for example, right now we are at 8 seconds or -8, but we want to see 0.8, just like in a normal clock. Okay, and for that we can again use the pad function. So let's convert this here to a string so that we can then call pad start, which should have the length of 2, and pad it with 0, or just the number is okay. And then the same here. And so now we should get a nice looking clock already. Let's actually start at 120 seconds, which is exactly 2 minutes. So you see now it's a nicely looking and nicely working clock, basically. So a countdown timer that starts counting from 120 seconds, which is exactly 2 minutes. And so that's why in the beginning the seconds is 0, because the reminder of doing 120 by 60 is 0, because 2 times 60 is exactly 120. Right? So 2 times 60 is 120, and therefore there is no reminder. So there are no seconds in our case. Okay? But let's not do it with only 10 seconds, because then we get that negative, and we can then work with that. So what we want to do here is as soon as we reach 0 seconds, we want to stop the timer and log out the user. So if the time is 0, then we need to stop the timer. And we do that by using clear interval. So remember in the last video, we used clear timeout to stop the set timeout function. And now we can use clear interval to do the same with the set interval timer. All right. Now, in order to make this work, remember, we need to give a name to this timer. So let's simply call it timer. And then here we can use that variable to indeed stop that timer. And then we want to log out the user, which basically means setting the opacity of this whole container here back to 0. So here in our login, we did the opposite. So we set the opacity to 100. And now logging out the user basically means setting it back to 0. And here this text content should also be set to something else. So not the name of the current user. So let's copy that. And so here the welcome label should say login to get started, which is basically also the default that we see right now, right? And then the opacity back to 0. And remember that usually when we first see the application, all of this is actually invisible. And let's do that here, actually. So get rid of this fake always logged in. So we did that before to test our code, but now it's no longer necessary. And so this is how the application is supposed to look like in the beginning. So we logged in, and now our timer down here is running. And so let's just see what happens once it reaches 0. And indeed, we got logged out here. Okay, so that works beautifully. But let me log in again here so I can show you something that happens and that we need to fix. So as I log in, it takes quite some time until something happens here. Maybe you didn't catch that, so let me try it again after we get logged out here. So I will scroll down immediately and then I hit enter. So you see, before it was still at 1 second. So it was the value that we had before. And that happened because this entire function here is only first executed after 1 second, right? So this callback function that we passed into setInterval is not called immediately. It will only get called the first time after 1 second. But in fact, we want to call this function also immediately, all right? And so the trick to doing that is to export this into a separate function, then call it immediately, and then also start calling it every second using the setInterval function. So let me just show it to you. So I cut the function here. Let's put it here. So we need to give it a name. I'm calling it tick because that's a pretty common name. And now I put it here. And so right now everything is exactly the same as before. But what I wanted to do is to also call this immediately. And so this is how we do it. And so now right away this function gets called, and then after that every 1 second. And so let's try it now again. Let me scroll down here. And you see, this time we didn't have that problem. Now it's simply not counting down, but that's because I did this small mistake here, which you see is very common in development. You will do this also all the time. And well, now we didn't see at the beginning of the timer, but believe me, now it's actually working correctly. However, you might have noticed that we still have a problem, which is the fact that actually we get logged out once this hits 1 second. And so watch closely now what happens when we reach 1. You saw that? And so that's not what we want to happen. This should only happen at 0 seconds, not at 1 second. And the problem here is that we decrease this time by 1 second before checking for 0. So basically the problem here is that in the iteration here, so in the call where the time is 1, right? So here it's going to be 1, and then we decrease to 0, and then we check for 0. And so in this iteration where the time is initially 1, this part of the code still gets executed. And again, because we increase that 1 second to 0 here before this. And so we need to put it after, of course. And so now this part of the code here only gets triggered if the time really is 0 here in this whole function. So now you will see that the logout will only really happen after exactly 10 seconds. So you saw it reached 0, 0, and then we got logged out. Great. So let's increase this here a little bit. And then I will log in as this user. So you see that it's running. And now I will also log in as Jessica Davis, just to see you yet another problem that we have. So you see, it's weirdly alternating between these two numbers. And the reason for that is that right now we have basically 2 timers running at the same time. So 1 timer of Jonas and 1 timer of Jessica. And so that's not at all what we need, right? That's a big problem right now. So how can we fix this problem? Well, basically what we can do is that whenever we log a user in, we check if there is already a timer running, and if so, then we stop that timer. So I believe that is the best solution to this problem. And so what I'm going to do now is to return the timer from this function so that we can then use it here in this callback function of the login and delete it in case that it exists. So let me write that code actually, and then it's going to become a lot easier to understand. So here we will return the timer. And that's important because to clear the timer, so to use the clear interval function, we need the timer variable. And so therefore I'm returning it here. So let's then save it here. So that's down here. And so this is going to be the timer. Now we actually need this as a global variable. So let me put that outside here. So the current account and the timer. And the reason for that is that we need this variable to persist between different logins. So otherwise, after this handler function here would be ready, then the timer variable would disappear. So that's the reason why we have current account out here, and it's also the reason why we need to keep the timer out here. That's the only way in which we can then actually check if it appears. So timer and current account both need to be in the parent scope of this function scope. So let me show you what I mean. So here I will then set the timer to the timer that is returned here. However, if there already is a timer, I first need to clear it. And so let's do that. So if there is already a timer, then clear interval timer. And that's it. So let's think what happens when I log in first as Jonas. So when I log in now, there's going to be no timer, right? So in this situation, there was no timer already, was it? There wasn't, because I just logged out for the first time, and so no timer variable was created. But now, since I did log in, now timer is equal to that timer that I just exported from this function using the return keyword. And so this timer now does exist. And so when I now log in as someone else, so Jessica Davis, for example, then when the code reaches this line here, then a timer will indeed exist. And so then that timer is going to be cleared. Okay. And so now there is no problem anymore. Okay, so now it's running smoothly without any problem. And that, of course, also works when the timer here has a higher value. Let's put it back to 2 minutes. So I can now log in. The timer starts running normally. And when I log in then as Jessica, then the timer gets cleared and reset basically, and it started again from 2 minutes. Okay. So all this might seem a little bit complicated, I know, but it's all kind of a matter of thinking about what we want our code to do. So all we're doing here is to use all the tools that we already know to basically achieve one goal that we want to achieve, which is in this case, this timer here running and being resetted each time that another user logs in. Now, another functionality that we want our timers to have is to basically reset once we do something in the account. Because remember, the goal of this timer here is to track the inactivity of the user. So the time where the user doesn't do anything. But if I do something, let's say transfer money, then we should not get logged out. It should be resetted. But as you saw, we still got logged out even after doing that transfer, of course. So what we need to do now is to also reset the timer whenever the user does a transfer or requests a loan. So these are the only two activities that exist in our application. And so these operations should always trigger the timer to be reset. Okay? So let's go here to the transfer. And let's do it here at the end. Reset the timer. So what does resetting the timer actually mean? Well, all we need to do is to basically clear interval using the timer that we already have and then start it again. So clear interval and then the timer variable. And so now one more time, it is important that this timer variable is actually a global variable. So a variable that's outside of any of these handler functions. So we define timer, remember, out here, because we didn't want it to be inside of this handler function here. And that was because we wanted this variable to persist throughout multiple logins. But now it's also important because we need it later for other operations. So inside other callback functions. And in particular in this one now. So clear interval of that timer that was defined previously, and then we simply start a new one. So basically we then overwrite that initial timer that we had before. So start, logout timer, and that's actually it. So imagine that the timer was at 1 minute 30 seconds. So when we do a transfer, that timer is cleared and a new timer is started again at 2 minutes. Okay, and now finally the same for requesting a loan. So let's try that. And now the timer is running down here. All right, and now let's try to transfer something to JD, so the other user, let's say 100. And watch what happens down here to the timer now. And indeed, it got resetted to 2 minutes. And the same when we request a loan, let's say 100. And then after the 3 seconds have passed, then our loan got approved indeed, and our timer reset to 2 minutes. Beautiful. Great. So our application is now actually finished and feature complete. Everything is working just as in our demonstration, and I think this was a great application to teach you really a lot of different stuff in JavaScript. So huge congratulations for finishing this great application. It's good to see that you made it to this point with me, and I hope that you're really proud of this application that you just built. You can now show it to all your friends and everyone that you're telling about your coding journey, and I'm sure they will be just as happy as you are about this amazing progress. So once more, great job and well done. And with that being said, I hope to see you soon in the next section where we're going to build together some features of a real website. So UI components that you find commonly in normal websites, such as sliders or pop-up windows. So that's going to be really exciting. So I hope to see you there soon.